Read code number 28, implement strStr. This is easy question. Let's get into it. Implement strStr, return the index of first occurrence of needle in haystack, while -1 if needle is not part of haystack. Let's check with example 1. Haystack is hello, needles is LL. So H is not L, okay, skip. E also not, let's skip. L is L, okay, and then second is the L, okay, so return index of first L, so 0, 1, 2, return 2. Okay, example 2, haystack is 5A and needle is BBA. This one is part of 1? No, so -1. How are we gonna solve it? Okay, let's start with the proper solution. First, I will scan this one to looking the needles, the first character. So when you found this one, and then I will iterate one more iteration, the size of the length of needles. So start to check is L is L, okay, L is L, okay. So return this index. And this time, time complex is M is length of haystack, and then M is length of needle at it, and then time complexity is MN, and then space complexity is constant. Can you make a better solution? Yes, there is the better solution, and then time complexity is M. How we gonna do? Do you have any idea? Okay, I will gonna use the hash value. So what means is that this is come from sliding window. So first I will make the window size is the same as needles. So first I will calculate the hash, and then it is each digit has the 26 value. So in this one 26, and then this one is 26 by 2. Did it make sense? That is, in case of the 10, this one is the 10 is the 0 to 9. So in this case, 9 is 9, and then this one is 10 multiplied 9. This one is same. So this one is 26 1, not 2, and if it there is the 20 multiplied 2. Did it make sense? Okay. So then we able to make the needles, and then also get the value the same size of here, because this one is the size of sliding window. And then when is the iteration, sliding window is the move. So when next time it will be here EL, and then how we calculate is deduct the H and then add the L. So that is the reason why it constant. So I will and after calculate, I will compare. This one is the same as this one. If same, I return the index, start index of sliding window. Otherwise, I will return -1. Okay, let's implement the code. So first we need to make the flying. Flying is 26. 26 is max amount of digit per digit, and then I will make the limit, because I don't want the integer overflow. So maximum integer is 2 to the 31, and then next I make the 2 hash. First it haystack hash, HA hash. Haystack hash is initialized with 0, and then needle hash is initialized with 0. And then now I will calculate the HA size. Its length as haystack, and then any size is length of needle. And then okay, now I am to make the sliding window. Okay, for in range same as needle size, I will calculate the HA hash is HA hash multiply flying, because the each iteration it going to next iteration, that digit going to move up digit. That is the reason why I put this one, and then next I will add. That is the second digit, and then now I add the first digit, the same as this one. First 1, and then if next value is 9, then in this time I will 10 plus 9, so finally we made 19. But in this time this one is the 26, so that is the reason why the prime is 26. And then plus I needed the function to change integer from string, and then string is the h hash, so haystack I, and then I will make one function to integer, and then receive argument as character, return I will use odd function, and then character minus odd, start with small a. First I will calculate needle hash, same way of HA hash, and then this one is needle. Okay, now we make the needle hash. This one is okay. Let me write this one. I will get example from here. Okay, now I calculated the HE. This one is the HA stack, HA hash. So HA hash here, and then needle hash is this. So first I will compare HA and then yes. So if this one is the same, if HA hash is same as any hash, I will return 0 because this one is the index 0, right? And then this one 0, 1, 2, 3, 4. Yeah. Next I will try to move this one to compare here to here. So I will iteration again in range from start from 1. This is 1, right? 1 to the haystack size minus any size, because in this case it cannot go to here, right? Because there are no data. But this is I is the start index of the sliding window, so I will delete this one. And this time this one deleted is the n is 2, so 1 2 now we here, right? So this is now final, so we need to add 1, so now it's here. Did it make sense? So in this time I will calculate HA hash is HA hash shift 1 shift left. So to shift is the multiply flying, and then minus I will in this time to move to here. Now is I here, so I will delete hash value from here h. So how I gonna do? Okay, 2 integer, and then this one is I minus 1, right? So haystack I minus 1, and then multiply. In this case, this one is now is this one is 0, and then this one is 26, and then this one is 26 multiply 26, right? So it is the same as power prime, and then same as length of needle. So any size. Did it make sense? So power any size, and then I will limit, and then finally I will add to this one L, right? To integer. This one is haystack I, and then I would like to make the limit to prevent overflow, and then reminder limit, and I will compare. If HA hash, that means new this one is the same as this one, I will return to this value. J hash is same as any hash, return index. If I cannot find anything, I return -1. And then let's make the be better. Actually this calculation is expensive, so I will pop this one and the put name is max line, this one, and then paste this one. Then it's this one just calculate one time, and then this one is same as fly to the any size, and then ampersand limit. Okay, let's check the code. Oops. Okay, there are something wrong. 26 right, you need the size. Okay, let's move this one to front. Primary size, right? Limit. Okay. J hash flying and trace the guy. Hash fly to line. Hash return 0. H size. Line and state limit. Like this one. Actually, okay. Let's check this one. So in this time we need to add this one, right? So this one, if the I is the only E, this is nothing, right? So how we gonna do? We will do this one is the length minus 1 because E plus needle is here, so this one minus 1 is here. This will be looking for. This one is not plus 1 because needle is changeable. In this case, needle value is 2, so just plus 1 is okay. But we must check needle is the not fixed, because this is the depend on the argument of needle. So any size minus 1 is correct. Oops. Okay. Side prime step minus 1. Then a step plus I plus any size minus 1. This is correct limit. H and H. So little I or little minus 1. It means 32. This is minor. Okay, we need to make the limit 2 here. Maybe this is the issue. Okay, now it looks good. Oh, we need to error handling. So what is this one? This one is the haystack is the length of haystack is smaller than needles. At this time, we need to return -1, right? So let's edge case handling. If each size is smaller than any needle size, we return -1. And then and there are one more thing. If needle is empty string, we needed to return which one? 0. Because empty string is all of the substring any words, right? Okay. Fix typo. Okay, that's okay. Let's check complexity. Complexity is the this one is big O M, and the M is length of needles, and then this one is big O M minus N plus. So in this case, M plus, oh sorry, this is N, needle is N, and M is length of haystack. So in this case, sum is big O N plus M minus N, so this one is deleted, plus 1 minus 1. So finally, time complexity is OM and space complexity is constant. Thank you.